Hello everybody. Now in this 10th lecture of the course today, we shall discuss the various aspects of quality assurance and quality control protocols. The concept which we will cover in this core subject or this lecture today will include quality and safety attributes of fruits, vegetable and other related commodities. What are the various factors which influence the quality and safety? We will also discuss about safety and hazards, and then continuous quality monitoring and spoilage detection. We will also take a brief overview of what are the various sensors which are used for the detection of freshness in fruits and vegetables, and finally we will conclude the lecture by discussing something on predictive modeling of quality attributes of fresh fruits and vegetables. Okay. So, let us see what does a quality of a material means. It refers to the rated ability of a product, whether it is processed product or fresh produce, to perform its functions, proper functions, that is the quality. Quality assurance is a system for evaluating the performance, service of the quality of a product standard or a specified requirement for customers. It is a systematic approach to provide adequate confidence of product and service. So, in the figure here you can see that quality system includes quality assurance and quality control. What are the relationship? Quality system is a bigger umbrella which includes quality assurance and finally quality control. For the evaluation of the quality of a particular fruit, vegetable or any other food, there are two types of methods. One is the objective assessment, other is the subjective assessment. Subjective assessment generally includes the sensory evaluation or sensory attributes like taste, aroma, size and flavor. In the objective method, generally instrumental approaches are used. Various instruments are used for measuring the quality attributes like pH, water holding capacity, vitamin and mineral content and so on. These objective methods may be further categorized into chemical method, physicochemical method, microscopic method or physical methods. Okay. In this slide, I have tried to give you an overview or what are the undesirable changes in the quality attributes, like for example, in the texture there may be loss of solubility, loss of water holding capacity, the material may become soft or it may become tough depending upon the various reactions and processes which are undergoing in these commodities. Similarly, in the flavor there may be a development of rancid flavor, either hydrolytic rancidity or oxidative rancidity depending upon the nature of the material. There may be cooked or caramel flavors, other off flavor development or color of the commodity may become dark, it may become bleach altogether, a new color may come, or there may be development of off colors. Similarly, nutritive value of the commodity may also get changed, and there may be this because of the either loss or degradation of micronutrients like vitamins, minerals, etc., or macronutrients like proteins, lipids and so on. Okay. Now, the food safety. What does food safety of a food means? That is, it is the assurance that food after we eat, it will not cause any harm to the consumer. That is, food will not cause any harm to the consumer when it is prepared and are consumed according to its intended use. That is meant by the food safety. Toxicity is capacity of a substance to produce harm or injury of any kind under any conditions. Hazard is the relative probability that harm or injury will result when substance is not used in a prescribed manner and in a prescribed quantity, desired quantity. And the hazards may be physical, chemical or biological hazards. Physical hazards means that any physical material which is not normally found in food, it may be due to any other reason present in the commodity, or chemicals which may be intentionally or unintentionally added to the food, or living organisms which may include various microbiological agents like bacteria, yeast, molds, etc. They may also come into the material and they may cause hazard to the food. Okay. Physical hazards in fruits and vegetables may be glass which may come from the various sources like bottles, jar or light bulbs, fixtures, utensils, gauges, etc. There may be wood sometime which will come from the field, or pellets or boxes which are used for packaging of the material. They may cause stones like broken teeth, fields or buildings, etc. from there. Insulation, that is building materials, or plastic, that is the packing, pellets, equipment, etc. So, from various sources, these are the various sources from which these physical hazards may come into the fruits and vegetables. So, identify possible physical hazard along the production chain and implement proper practices and countermeasures, and create awareness and responsibility among the workers to ensure that the commodity is free from any such physical hazards. Chemical hazards which may be found in the fruits and vegetables, and obviously if it is there, it can pose a serious health hazard if they contaminate fruits and vegetables in significant concentrations. There are in many commodities, there are naturally occurring chemicals like allergens, like in the wheats or peanuts, etc. Many people are allergens to nuts, etc. And then if this is present, then it may cause various lot of allergic reactions leading to severe, even sometimes severe health problems. Similarly, there may be fungal toxins present in the material like mycotoxins, aflatoxins, etc. or phytohemagglutinin. So, they may also cause multiple poisoning, either acute or chronic. Alkaloids, etc. may be present in the food materials, they also may cause multiple poisoning, acute or chronic. So, these make minimal and correct use of chemical additive. This is as a rule of thumb, that is, as far as possible the use of chemical in any food may be avoided, and wherever it is necessary, minimum possible concentration should be used. For example, agrochemical or processing and treatment agents, packing additives or pest control agents, antibiotics, etc. All these, if they are used in excessive quantity or if their residue remains in the material, it may be a potential health hazard. So, one should take care. Similarly, biological hazards in fruits and vegetables may be contamination with bacteria, fungi like yeasts and molds, or parasites like protozoa and helminths or viruses, etc. So, the primary sources of microbial contamination of fresh fruits and vegetables are, that is, untreated manure or feces or municipal biosolids and sewage fluids. They cause, when you put all these things in the plant, then plant accumulate these contaminants and microbial biological contaminants, and this comes through the plant, it comes into the fruit or vegetable, etc. If contaminated water is used either in the field for agricultural purposes or for processing, this water is contaminated, that may be another source. Then contaminated soil, dust, surroundings and handling equipment, and poor sanitary practices in the field as well as in the processing plant, or where the equipment or the material or in the where it is being handled. So, poor sanitary practices may also lead to this biological contamination. So, the food safety management system, that is food safety and quality, can be measured through proper implementing either proper GMP, that is good manufacturing practices, good hygienic practices, or HACCP, that is hazard analysis and critical control point. That GMP is the proactive step to ensure that products are safe. It eliminates contamination and false labeling, thereby protecting the consumer from being misled. GMP also helps to refine the compliance and performance. These GHP and HACCP, they are used to identify potential sources of risk. They are the steps to minimize the risk of contamination. It ensures that all persons who handle the food have good hygienic practices, or they observe good hygienic practices. Okay. HACCP, I told you, it is a systematic preventive approach to food safety that addresses physical, chemical and biological hazards as a means of prevention rather than finished product inspection. There are 7 chronological steps of HACCP, which is commonly known as 7 principles of HACCP, which includes first is the hazard analysis, that is conduct a analysis and identify what are the potential hazards that may create problem. Then determine the CCP, that is the critical control point in the food processing, that is in the value chain. Then critical limits, establish that critical limit for preventive measures, and after that establish a procedure to monitor that CCP. Okay. Once you have done that, then establish a corrective action, that is when monitoring shows that a critical limit has exceeded or it has not been followed or implemented properly, then what should be corrective action. So, that also should be established, and then finally that establish verification procedure, that is whether CCPs are proper value chain or proper this monitoring is in force or not, SOP is in force or not, that there will be some procedure for verification of that, and finally establish record keeping and documentation. So, these are the 7 steps of HACCP implementation in the food processing industry. As far as the quality attributes of fresh fruits and vegetables are concerned, they can be classified into 3 groups according to the occurrences of the product characteristics, like it may be external quality attribute, internal quality attributes or hidden quality attribute. External quality means appearance, feel, touch or such other defects, and it can be measured either by visual evaluation of size, shape, gloss and color, or there are visual guides and colorimeters, manual evaluation of firmness and texture by mechanical texture analysis, or evaluation of absence of defects or deterioration of color. It can be used several mechanical methods like ultrasound, etc., which we will discuss in next slides. And so, then the internal quality like odor, taste, texture, etc., these can be there are qualitative or subjective methods which can be used for finding out these odor we discussed earlier, like sensory methods as well as instrumental methods, etc., can be used. Instrumental methods are like gas chromatography, e-nose, etc., are becoming more popular nowadays. Then oral testing, sensory evaluation of sweetness, bitterness, sourness, etc., or technical quantification of the taste compounds using HPLC, so can be done. Texture profile like firmness, tenderness, mouthfeel, etc., can be measured by applying the force to the produce and analyzing that how much force is required to break or rupture the product. Wholesomeness or nutritive value or food safety attributes, which are considered as a hidden quality attributes, they can be analyzed by again laboratory methods, instrumental methods. There are macro and micronutrients, phytochemicals, etc. There are a standard set of procedures, protocols which can be used to find out these. Examination of food item with regard to their pathogenic microbial load, content of chemical contaminants and presence of foreign matters, etc., should be analyze, and in fact this hidden, particularly food safety, nutritive value, etc., bacterial contamination, it can be give an idea that how clean, how safe the food is to consume. Okay. Here are some non-destructive methods for continuous quality monitoring for food as a general, or fruits and vegetable in particular. These methods can be used, like these methods may be optic, X-ray, mechanical method, or electromagnetic method. In optic method, like image analysis, can be used for determining the size, shape, color, reflectance or absorption, can be used to find out if there is any external defect in the commodity. Similarly, reflectance spectroscopy can be used for internal component analysis or color, etc. Okay. Laser spectroscopy can be used to find out firmness, viscoelasticity or shape of various commodities. X-ray image and CT can be used to find out internal cavity and structure of the product, of the produce, or even degree of ripeness, whether the material is fully ripe or less ripe, etc., that can be found out. In the mechanical methods, vibration or vibrated excitations can be used to find firmness, viscoelasticity, ripeness. Sonic method or ultrasonic method can be used again to find firmness, viscoelasticity, internal cavity, density, sugar content, tenderness, firmness, etc. Okay. Electromagnetic methods are used to find, like impedance are used to determine moisture content, density, sugar content, internal cavity, or MR or MRI can be used to find out sugar content, oil content, moisture content, or internal defect, any structure, internal structure of the material. So, we will take up briefly the brief overview of the principle of these methods, like optical methods first. These optical properties are based on reflectance, transmittance, absorbance or fluorescence, or even scattering of light. So, any of these properties can be used to determine the optical characteristics, and in one you can say time resolved reflectance spectroscopy. That is, it's a principle, it's set up here shown in the line diagram. That is, this method involves the penetration of light into a diffusive medium, which depends on the optical properties of the medium and on the source detector distance. In case of fruits and vegetable, the depth of the probe volume is of the same order as the source detector distance. Information on internal quality of fruit, as it measures the bulk properties, not the superficial characteristics alone. So, this method can give information about the internal quality characteristics. It is suitable for grading, maturity determination, and detecting the internal defects, and in predicting the shelf life of the food materials. Okay. That is, you can see here that is the various drivers are there, which give the fiber optic through cables, and it gives that information to the spectrophotometer, and it emits either scatters or the light, which is red, that there are the filters and optics through these lamina. Okay, it is coming. Okay. Then visible or near infrared spectroscopy. This about 780 or 25,000 to this range, nanometer range in electromagnetic spectrum can be used for analyzing various properties. Okay. That is, it is used in fruit firmness measurement and detection of visible blemishes, soluble acid content, dry matter, hygroscopy, firmness, sugar content, acidity, etc. can be determined. Even the fruit maturity of fruits like banana, apple, tomato, mango, okay, has been evaluated using the or by measuring the skin color of these using visible or NIR spectroscopy. Okay. And here again there is a spectroscopic camera, there is a monitor, like you can see here the figure. Grapes are a bunch of the grapes, either individual grapes, their peels can be taken in the cuvettes, and this is sent to the micro NIR with an adapter or micro NIR, which reads the spectra and send the information to the laptop or computer, where it is by various PCA or other sample selection, quantitative method or qualitative method. There are some software which analyzes the spectra and gives the output. So, application of portable micro near infrared spectroscopy to the screening of extractable polyphenols in the grapefruits is shown here in this figure. Okay. In the dynamic method, that is X-ray imaging, that its maturity and various internal defects in fruits can be analyzed using this technique, that is like freeze damage or internal browning or presence of pits, if any, in the fruits, presence of foreign particles, infested fruits, etc., exhibit changes in the density and the water content, and this property is used, imaged by using X-rays. Okay. The X-ray radiography and X-ray computed topography, the CT scanning are widely used method. Okay. Infestation in apple, peach, pears, cherry, tomato and orange have been detected successfully using this X-ray imaging. So, here again there is a computer, there is a control panel through high tension transformers, etc., and then high tension insulated cables. With the help of this is X-ray image, and X-ray digital X-ray sensor is there, which absorbs the data, all right, take the data and passes it on to the computer, where it is analyzed using appropriate software and the output is given. Then gas sensor array, in the mechanical method gas sensor array or electronic nose. Okay. It is a chemical and electronic sensors are there in the electronic nose, which stimulate the functioning of olfactory system. That is what we do in our brain. That is, whenever we sense any commodity comes to our, that is a nose, the smell we sense, and this is sent to the olfactory system, where the data is analyzed and it gets its impression to the brain. So, similar setups are there in a instrument, where there are various these sensors are there, that is the various sensors, that is data processing unit, software and digital pattern recognizing algorithm, and a reference library. That is, when you ever give you any sample, this samples, that is this vaporized, that is volatile components which are present in the sample, which are responsible for the flavor, these are that is vaporized, and then they are sent to the this GC chamber or this e-nodes, where various metal oxide or such other sensors are there. Okay. These sensors interact with the volatile compounds non-selectively to produce signal, and this signal is read by the computer, which is called as electronic finger point, and then this signals is read, and already there is the computer. Suppose you want to find out that yes, this is spoiled mango and fresh mango. So, first you have to give that is fresh mango, it will read and will prepare the library, that is yes, what a fresh mango is. Then when you give any spoiled mango, it will take the image, it will take the data sensor volatile components, and on the basis of flavor it can segregate that yes, the flavor of this particular mango is not meeting with the flavor of good quality mango, and then it can segregate these two on the basis of two sets. Okay. So, this is basically the principle of gas sensor array or electronic nose. Then the acoustic impulse response method, like it is used to analyze the texture of fruits. It uses natural frequencies of the intact fruit, which is obtained by recording the sound that produced by hitting the fruit, and it performs Fourier transformation on the signal. That is, when any material is impact. So, whatever when you put it impact, whatever sound is produced, that sound is recorded, and then by Fourier transformation, etc., on the signal, it is analyzed. It analyzes the impact. Similarly, ultrasonic waves, that is the surface wave transmission, it is the surface wave transmission technique, and it is used to detect density, moisture content and firmness of many commodities. Even but in the case of oranges, it has been successfully applied or used by a few researchers. Okay. In the electromagnetic method, that is nuclear magnetic resonance techniques are also there, which is absorption of magnetic energy by nuclei placed in an alternating magnetic field. Amount of energy absorbed by the nuclei is directly proportional to the number of protons present in a sample. It determines freeze damage by locating the spatial NMR signals. It is useful in detection of pits in fruits and vegetables. Spectra can be interpreted easily and differentiate healthy and freeze damaged oranges. That is, this system has been used, like oranges etc., healthy and oranges. Okay. So, that this method, nuclear magnetic resonance techniques, can also be applied for determination of various quality. Then nowadays it is becoming very popular, that is machine vision system. The machine vision system usually consists of 5 basic components, that is a light source, an imaging unit, an image capture board, computer hardware and software. So, an automatic machine vision system was industrialized to detect small insects even in the raspberry fruit holes. Okay. So, you see here the light source, that is commodity here in this, it is the tomato is in, then light source is there, it emits the light and it is sensed by the camera, and this camera send the signals to the computer CPU, where it monitors and finally analyzes the image, and then finally send that its impression and result to the, it displays in the monitor. Okay. Hyperspectral imaging is also done in similar way. This is the basic principle, is that the food reflects, scatters, absorbs and produces electromagnetic energy in different forms at particular wavelengths. The reflectance is plotted against the wavelength and the curve is referred to as the spectral signature of the constituent. Determines firmness, total soluble solids, titratable acidity of mangoes in the spectral regions of 450 to 998, and the system contains lighting source, sensor which accurately acquires a spectra, a spectrograph or computer to produce the acquired images. Okay. In this slide, I have just tried to say you that yes, now we will devote some time on determination of the different freshness parameters. So, like these fruits on the basis of their classification, for example, ripeness, climatic fruits, non-climatic fruits. So, for climatic fruits like ethylene production, humidity or temperature, time maintenance inside the storage environment, that may be taken as criteria for the quality determination. Similarly, that the different fruits like dry fruits, it can be like that is spoilage or leak or the microbial contamination can be taken. In the case of multiple fruits, that ethylene or microbial contamination or spoilage can be taken as indicator for freshness, etc. So, here just I have given you different types of fruits, their different classification and what can be the freshness indicators, like whether the material is good for consumption or not, or either has been spoiled. So, the various sensors are used to detect these, their freshness or using abilities. So, classifications of sensors for monitoring the freshness of fruits. There are direct sensors like those who can detect spoilage, ripeness, leak, microbial contamination, ethylene glass production, etc. Or indirect methods may be humidity and temperature control sensors or time TTI levels, time temperature indicators, etc. Okay. So, this direct methods, it detects a particular analyte directly from the fruit as an indicator of the food freshness, and the indirect methods are those based on the reaction based detection of fruit degradation due to certain freshness parameters such as temperature and time. So, you can see that spoilage sensors, spoilage can be detected using chemical sensor including pH sensor. The pH of the enclosed fruit package changes within the head space, which can be measured by using a pH sensor. Formaldehyde was detected by exploiting the chemical reaction between the formaldehyde and the primary amines. Okay. Then similarly, ripeness sensor, that is a sensor react with the aroma emitted by the ripening fruits like pears, kiwi, melon, mango, etc. and different stages of fruit ripeness can be studied using even ENOJ. Okay. Colorimetric sensor, it was developed method that utilizes the pH indicators based on methyl red to detect aldehyde emission as a marker of the apple ripeness, and this can be used for similar such other fruits. The detection setup is here. Okay, and in this figure you can see the degree of sensory ripeness and RGB index in the class, or their relationship is shown. Okay, and there are various color changes in the sensor label after exposure to apple flavors, and on the basis of these color changes one can get an idea about its freshness or spoilage. Similarly, the indirect sensors like humidity sensors are there. A capacitive humidity sensor is a type of humidity sensor, hygrometer, that utilizes change in capacitance to detect relative humidity levels. That is the initial setup of captive sensor. You can see in the figure, it indicating no detectable voltage across the plates, or the introduction of a water vapor in the atmosphere is shown here in the second figure. Okay. Then the change permittivity of the dielectric because of the water vapor generating a detectable voltage on the plates, and that is measured by these sensors. Time temperature indicators, that the chemical and physical mechanisms are based on a chemical reaction or a physical change respectively due to changes in the time and temperature, and there are various TTI indicators are available in the market, which can given like in the whether you can see here it is black spot, it shows means it should not be used, or even that there may be some sort of index and the time is stripped depending upon it during the storage, and during storage if there is any change takes place, then these are the various sensors, and that is 1, 2, 3, 4. So, if it is goes like third level, it is glows or fourth, then it is that it should not be used. Similarly, in the figure C here, it is shown monitor mark, that is it can be like in service, and whether it is after 6 months or 7 months, that it can be used, or checkpoint like here you can see D, that is do not use if the circle is in pink. So, various combination and permutations one can use it using nanotechnology, and these sensors are produced which can give you the desired information. They inform the consumer about the thing. Then traceability and RFID based sensor indicators, okay, that is a RFID technology is used to track and identify the product quality during storage and transit. These systems require an RFID tag with an antenna and an RFID scanner, and utilize radio waves to communicate data to a network, and these active tags allow the real time traceability as they can constantly send out information. Freshness sensors are being employed commercially with RFID tags to monitor relative humidity, temperature, light exposure, pressure, pH of foods, etc., or even during transit they are used whether the material is in good condition or not. Food traceability using a smartphone and tracking and tracing across the supply chain is used. That is even one can develop the app in the mobile, and then RFID such this data can be taken on the smart app. So, that is the smart apps or cloud storage this data. Finally, that predictive modeling of quality parameters of fruits and vegetables, that is artificial neural network is one such model which is mostly used. ANN draws on previously gathered information and uses this when analyze new data point. So, for pattern detection, it may make the electronic nose application more powerful for fruit quality analysis. So, neural network models are used to predict the shelf life of green house lettuce or many such other commodities. So, using 2-stage ANN models, some models were developed which could achieve for predicting the shelf life of the product. So, in this there are some input layers like time or some particular quality attributes. It goes bias, it analyzes the bias and send it to for the hidden layer, and finally on the basis of this net models analyzes and give the model output maybe of any particular desired quality like weight loss, pH, calorie, ion exchange and so on. Okay. So, finally I would like to conclude this lecture or summarize by saying that the transformation of quality assurance from external into internal parameters in fruits should be accomplished by a reliable mechanism to evaluate the standards. Quality control and quality assurance allows to test that what the consumer is expecting will be effectively fulfilled. Current sensor and communication technologies can provide means of monitoring and regulating the quality of the packaged fruits, vegetables and such other commodities. Artificial neural network and genetic algorithm are analytical alternatives to usual modeling methods. Consumer awareness is must about health hazards to chemical and hormones used in malpractices, and consumer must respect or consumer must report to the regulatory bodies if they found there is any malpractice in the value chain or if the commodity or material is not of desired quality and safety standards. These are the references which were used in this lecture, and finally thank you very much.